Okay, so yeah, so work on those progress. Okay, so why don't we look at 23 first? Okay, 23. So 23 probably 23 is too easy. Why? Because the sequence is 1, 1/2, a quarter, 1/8, 1/16, right? Look, if I look at this, it's so obvious. The AN, right? Okay, the first term is 1. The second term is 1/2, right? The third term is a quarter. So what should this be? You see, this looks like this 4 is like 2 squared, right? So so if I look at this, you see this is 1/2 to the 0. This is 1/2 to the first. Yeah, and then a sub 4, 1/8, which is 1/2 cubed. Okay, so after this is really try by error, and I look at it, I guess this looks nice, right? This is okay. So therefore, what's A? The question A is what? They want us to find the next 2 terms. Oh, okay, I already have it. Next 2 terms. Okay, next 2 terms. So the A1, A2, A3, A4, A5. The next 2 terms, right? So A6. The next one is what? 1/2 to the 5, which is because A to the 5 is 1/16 is 2 to the 4, 1/2 to the 4. So A to the 6 is 1/2 to the 6, 1/32. The next 2 terms, this guy, is 1/2 to the 6, 1/64. Okay? B is what? Find a recurrence relation. Okay. So I look at this. I know what it is. A sub n should be 1/2 to the n minus 1. Surprise here. So when n, so A1 is 1. This is the relation. Okay. And then C, find an explicit formula for the nth. I will see it. I will have this. Another thing of writing this, I probably should write. I can write this as the following. Let me write this, okay? Because if I look at this, I see that each term is 1/2 of the previous one. So I can write it as A sub n plus 1 equal to 1/2 A sub n. Okay, this is recurrence. When n is 1, A sub 1 is 1. And when n is 1, it is 1/2. When n is 1. And for A sub 2, it is 1/2 of A1, which is 1/2. When n is when A sub 3, right? 3 is when n equal to 2. A sub 3 is 1/2 of A2. A2 is 1/2, so a quarter. So this is right. Okay. So this is better. Okay. So I have this. Right. So this is. Okay, and those are the questions they are looking for. Any questions so far? All right, so let's look at perhaps, how about 29? Same questions, okay? 1, 3, 9, 27, 81. Okay, so I look at it, so it's simple. Okay, so they want us to find the next 2 terms of the sequence, right? Next 2 terms. If I look at this, 3 times 1, 3 is 1 times 3, 9 is 3 times 3, and so on. Okay, so I know the next 2. A will be what? 3 times this, 243, and then the next two, right? So 7 to 9. Okay. B, find a recurrence of relation. Okay. Well, as I can see, each one is 3 times of the previous one. So A sub n plus 1 is 3 times. The current one is 3 times the previous one. And then the first one is 1. So here is supply the initial value of the index and the first term of the sequence. Okay. C is find explicit formula for this. Okay, so actually if I look at this one, right, this is A sub n equal to 3 to the 3 to the n minus 1. When n is 1, it's 0. When n is 2, it's 3. When n is 3, it's 9. Okay. So this. Okay, so the next group of questions is about the limit of the next group.
I have a question.
Yes, go ahead.
What's the difference between B and C? Like, what are the questions for B and C?
B and the C. Okay, B is that they want us to find a recurrence relation. Normally, recurrence relation is a relation. Good question. Okay, a recurrence relation. Let me copy this word right. Yeah. Recurrence. Normally, recurrence relation is a relation. This is a relation among current, I would say, element. I mean, current number or element, and the previous elements. Okay, I'm calling it elements or numbers, terms. I would say maybe current terms. Yeah, current term, and then the previous terms. Okay, so this is a recurrence form. This is a recurrence relation. So any, let me see. Can you see it here? So anything here. Yeah, anything here. 17, 18, 19, 20, 21, 22. Anything here is a recurrence relation. Anything here, from 9 to, you see, there's a difference between 9 to 16 and 17 to 22. Now, what's the difference? The difference between these two is that from 9 to 16, they give you explicitly what it is. So A sub n is 1 over 10 to n, exactly what it is. All you need to do is just to replace n by, say, 1, 2, 3, 4, and so on to get each term of the element, of the sequence. But from 17 to 22, the way they give is a little bit different. It is, they give you a relation between the current one and the previous one. See, current one and the previous one. Current one and the previous one and something. Current one and previous. So a recurrence relation is a relation among the elements itself. A formula, explicit formula, is a formula that tells you exactly what that one is. Right? So if you compare, these two are different. The expressions, the way they express the terms are different. Anything like this is called recurrence relation. Anything like this is a formula. So that's why when I work out B and C, for B they ask for recurrence relation. They ask for recurrence relation. And for this one they ask for formula. Okay. So you see, for the B, I don't think I can still call it B, find a recurrence relation. So this is a recurrence relation. And recurrence relation is a relation among the terms of the sequence. A formula is just explicitly, an explicit expression which you can just directly evaluate each term. So those two, it's just the expressions are different, so they use different names. This is called recurrence relation. This is called formula. Explicit formula, recurrence relation. Okay. All right. Let's look at next group of questions. What's the next? Oh, next group is to determine whether they have limit. So write the terms A1, A2, A3, and A4, so 4 terms of the following sequences. If the sequence appears to converge, make a conjecture about its limit. If the sequence diverges, explain why. Okay? So this is, so the definition is very simple, right? I explained it before. Convergent means limit exists. Divergent means the limit doesn't exist. Okay, so we just, all we need to do is just really look at the limit. So how about, let's say 31. Okay, so I'm looking for number 31. Is a sub n equal to 10 to the n minus 1, n equal to 1, 2, 3, blah, blah, blah. Okay? So the first 4 terms of the sequence is what? First 4 terms, right? A1, A2. So A1 is 10 minus 1, which is 9. A2 is what? 10 squared minus 1, that's 99. A3 is 10 cubed minus 1, that's 999, right? A4, 10 to the 4 minus 1. Well, if I look at those numbers, right, getting bigger and bigger. So therefore, limit, I can safely say this limit doesn't exist. It doesn't converge to a number, it's getting bigger and bigger. 999, 999, 9,999. You can imagine what will be the next numbers, okay? So it doesn't exist. Okay, so that means, yeah, so the one on one side. If the sequence diverges, so you say, oh, this sequence is divergent. Okay, because the limit doesn't exist. Alright? Okay, so how about let's look at, say, about 35. A sub n is 1/2 to the n, 2 to the n. Okay? And n is 1, 2, 3. Okay? So, alright, let's write the first few. So A1 is what? When n equal to 1, right? So negative 1 over 2. A2 is 2, right? So it's negative 1 squared over 2 squared, which is 1 over 4. A3, negative 1 cubed, 2 cubed, that's minus 1 over 8. A4, negative 1 to the 4, 2 to the 4. So that's 1 over 16. All right, so does this appear to converge? Well, let's think about it. Let's say this is 0. A1 is negative 1/2. Let's say this is 1. Okay. Negative 1 is negative 1/2. So A1 is here. A1 is here. Where is A2? A2 is a quarter, right? So A2 is here, a quarter. Where's A3? Negative 1/8. Oh, it's here. So it's